Where can you find quadrilaterals? Well, just about all over the place, even here in San Diego in the Hotel del Coronado. And quadrilaterals come in lots of different forms, just like you know from your project. They look like this. They could be squares, kites, rhombuses, kites, trapezoids, rectangles. They're all there. But today we're going to be focusing on ways to prove that it's a parallelogram. Today is pretty easy for setting up your notes. You're going to start off with your page, your daily agenda, and then last but not least, you have a little glue-in for me that you're going to put at the very bottom. The rest of our notes you can put in this top portion. You can say a quadrilateral is a parallelogram if it meets one of these requirements. So what I'm saying is, if it has 4 sides, you can check these requirements, and if it meets those requirements, then that 4-sided figure is a parallelogram. Now these are 4 theorems. We're going to write them all down, and this is the only thing you're going to be writing at the top of your paper. So it's a parallelogram if, here we go, we're going to start off with theorem 5-4. A quadrilateral is a parallelogram if both pairs of opposite sides oh my goodness, are congruent. So here's one option, theorem 5-4, if both pairs of opposite sides are congruent. Here's another one, theorem 5-5, if one pair of opposite sides are congruent, wait for it, and parallel. So you can say that a quadrilateral is a parallelogram if both pairs of opposite sides are congruent, or if one pair is congruent and parallel. So it'd have to be both parts. Your next one says, the next one is theorem 5-6, and it says it's a parallelogram if both pairs of opposite angles are congruent. Let me move that out of the way here. I'll move this over here. So let's recap. If both pairs of opposite sides are congruent, if one pair of opposite sides are congruent and parallel, or both pairs of opposite angles are congruent. Now there's actually just one more, and this one is theorem, let me get it in here, here we go, theorem 5-7, and theorem 5-7 says it's a parallelogram if the diagonals bisect each other, then it is a parallelogram. I've got to move that over here. So if the diagonals bisect each other, then it is a parallelogram. Now I'm going to actually go ahead and name these. So I'm going to call this one A, B, C, and D when I'm referencing them. So just kind of keep that in mind when we're filling in our graphic organizer. And believe it or not, that's kind of the bulk of our notes today. But I'd like you to really think about what these 4 different theorems are saying and what criteria they're looking for. So the first thing we're going to need to do is name the shape. And I know the space is kind of small, but let's go ahead and do that. So what I'd like you to do is think about what these are and then unpause to check to see if you've named the shapes correctly. All right, let's see what you did. This first shape is a square. Okay, it's a square because all sides are congruent and the angles are right angles, so that's a square. And if that's a square, then the second one must be a rectangle. Rectangle. Our third one has parallel top and bottom base, but the sides are kind of askew. This one's called a trapezoid. Did you get that one right? I hope so. And the last one is what I would call a square with attitude. I know it's a square because all the sides are congruent, but it has attitude because it doesn't have right angles. This is a rhombus. Now we're going to use these 4 shapes to kind of figure out, is it a parallelogram, yes or no, thinking about those 4 theorems. Okay, now that we know what each of these shapes are, we're going to go ahead and ask ourselves, is it a parallelogram and why? Starting off with a square. A square is a parallelogram, and the question is, why? Now, we're only going to be looking at the markings on this shape. So there may be some additional things you know about a square, but we're not going to talk about those. We're only going to talk about what's shown. It's a little bit hard to see here, but all 4 sides are equal, and you've got 4 right angles. So what's one reason that it's a parallelogram? Well, how about opposite sides are congruent? That's definitely one reason why it's a parallelogram. That's our very first theorem, theorem A, so to speak. Now, there's actually another reason we could say that. Also, both pairs of opposite angles are congruent. That's 2 reasons why a square is a parallelogram. How about the second shape, the rectangle? Do you think it's a parallelogram? I'm going to go ahead and say, yes, it's a parallelogram. Well, 1, both pairs of opposite sides are congruent. And second, again, both pairs of opposite angles are congruent. They both just happen to be 90 degrees. Now, because there are no diagonals here, I'm not going to be using those. What I'd like you to do right now is I'd like you to try the last 2 for the trapezoid and the rhombus. Go ahead and pause the video, and then unpause when you're done, and let's see if you can say why it is or is not a parallelogram. All right, let's see how you did. For the trapezoid, is it a parallelogram? Did you write no? I hope so. It's not a parallelogram because it does not satisfy any of these 4 different requirements. So here I just asked that you write NA. So both pairs of opposite sides aren't congruent, parallel, or same to speak with the angles. Last but not least with a rhombus is a parallelogram. And let's see what's given here. Well, again, what do you know? Opposite sides are congruent. Well, all of the sides are congruent. It's kind of like a square. And again, as labeled in this picture, and it might be hard to see, but angle B is congruent to angle B, and angle A is congruent to angle A. Opposite angles are congruent, both pairs, so that means that is they are parallelograms because of these 2 reasons. Now, when you're showing a shape as a parallelogram, you only need to show one thing, but because these are very special quadrilaterals, that's why we have kind of multiple options here. Now, keep these in mind, and good luck if you work on any proofs.